Welcome to our journey into the world of statistics. Whether you're a student, a professional, or just someone curious about how data shapes our world, understanding basic statistical terms is essential. In this video, we'll break down the most important concepts in statistics, making them easy to grasp and apply. From understanding what data really means to exploring how we summarize and interpret information, you'll gain the foundational knowledge needed to navigate reports, research, and everyday decisions. Let's start by setting the stage for why these terms matter and how they help us make sense of the numbers all around us. Data is the backbone of statistics. It refers to the raw facts, figures, or information collected for analysis. Data can be numbers, words, measurements, or even observations. For example, the heights of students in a class, the number of cars passing a street, or survey responses all count as data. Understanding what data is and how it's collected is the first step in any statistical analysis. As we move forward, keep in mind that data comes in many forms and is the starting point for all the terms we'll discuss. Data isn't all the same. It comes in different types, each with its own characteristics. The two main categories are qualitative or categorical data and quantitative or numerical data. Qualitative data describes qualities or characteristics like colors or names. Quantitative data, on the other hand, deals with numbers and amounts such as age or income. Recognizing the type of data you're working with is crucial, as it determines which statistical methods you can use. Statistics, we often talk about populations and samples. Population includes all members of a group we want to study, like every student in a school. A sample is a smaller group selected from the population, such as just one class. Since it's usually impossible to study an entire population, we use samples to make inferences. Understanding the difference helps us know how reliable our conclusions are and how much they might vary. Variable is any characteristic or property that can vary among individuals in a study. For example, height, weight, or favorite color are all variables. Variables can be classified as qualitative or quantitative, just like data. Identifying variables is a key step in designing a study or analyzing data, as it tells us what we're measuring or observing. Statistics is often divided into two main branches, descriptive and inferential. Descriptive statistics summarize and organize data, helping us see patterns or trends. Inferential statistics, on the other hand, use data from a sample to make predictions or draw conclusions about a larger population. Knowing which branch you're working with helps clarify your goals and the tools you'll use. Mean, often called the average, is one of the most common ways to summarize data. To find the mean, you add up all the values and divide by the number of values. For example, if 5 students scored 80, 85, 90, 95, and 100 on a test, their mean score would be 90. The mean gives us a sense of the typical value in a dataset, but it can be affected by extremely high or low values. Median is another measure of central tendency. It's the middle value when all the data points are arranged in order. If there's an odd number of values, the median is the one in the center. If there's an even number, it's the average of the two middle values. The median is especially useful when data includes outliers, as it isn't affected by extremely high or low numbers. Mode is the value that appears most often in a dataset. Unlike the mean or median, there can be more than one mode if several values tie for the highest frequency. In some cases, there may be no mode at all. The mode is especially helpful for understanding what's most common in a set of data, such as the most popular ice cream flavor in a survey. Range measures how spread out the values in a dataset are. It's calculated by subtracting the smallest value from the largest. For example, if the lowest test score is 60 and the highest is 100, the range is 40. While the range gives a quick sense of variability, it only considers the two extreme values and ignores the rest. Variance is a measure of how much the values in a dataset differ from the mean. It's calculated by finding the average of the squared differences between each value and the mean. A high variance means the data points are spread out, while a low variance means they're close together. Variance is a key concept for understanding data variability and is used in many statistical analyses. Standard deviation is closely related to variance. It's the square root of the variance and gives us a sense of how much values typically differ from the mean. A small standard deviation means most values are close to the mean, while a large one means they're more spread out. Standard deviation is widely used because it's in the same units as the original data, making it easier to interpret. Frequency distribution shows how often each value or range of values occurs in a dataset. It can be displayed as a table, chart, or graph. Frequency distributions help us see patterns, such as which values are most common or how data is spread out. They're a fundamental tool for summarizing and visualizing data. Histogram is a type of bar graph that shows the frequency distribution of numerical data. Each bar represents a range of values, and the height shows how many data points fall within that range. Histograms are great for visualizing the shape of data, such as whether it's skewed or symmetrical, and for spotting outliers. Probability is the measure of how likely an event is to occur. It ranges from 0, impossible, to 1, cert. For example, the probability of flipping a coin and getting heads is 0.5. Probability is a core concept in statistics, helping us make predictions and assess risks in everything from games to business decisions. Random variable is a variable whose value is determined by the outcome of a random event. For example, the number of heads in 10 coin tosses is a random variable. Random variables can be discrete, taking specific values, or continuous, any value within a range. They're essential for modeling uncertainty and making predictions in statistics. Parameter is a value that describes a characteristic of a population, like the average height of all adults in a country. A statistic, on the other hand, describes a characteristic of a sample, such as the average height in a surveyed group. Understanding the difference helps clarify whether we're talking about the whole group or just a part of it. Levels of measurement describe how data can be categorized and analyzed. There are four main levels: nominal, ordinal, interval, and ratio. Nominal data are categories without order like colors. Ordinal data have a meaningful order like rankings. Interval data have equal intervals but no true zero like temperature. Ratio data have equal intervals and a true zero like weight. Knowing the level helps choose the right statistical methods. Outliers are values that are much higher or lower than the rest of the data. They can occur due to errors, unusual events, or natural variation. Outliers can have a big impact on statistical measures like the mean and standard deviation. Identifying and understanding outliers is important for accurate analysis and interpretation. Correlation measures the relationship between two variables. If both variables increase together, the correlation is positive. If one increases while the other decreases, it's negative. Correlation is usually measured on a scale from -1 to 1. A value close to 1 means a strong positive relationship, while -1 means a strong negative one. 0 means no relationship. It's important to remember that correlation does not mean causation. Just because two variables move together doesn't mean one causes the other. For example, ice cream sales and sunburns both rise in summer, but buying ice cream doesn't cause sunburns. Distinguishing between correlation and causation is crucial for drawing accurate conclusions from data. Normal distribution, often called the bell curve, is a common pattern in statistics. Most values cluster around the mean, with fewer at the extremes. Many natural phenomena like heights or test scores follow this pattern. Understanding normal distribution helps in making predictions and identifying unusual data points. Skewness describes how data is distributed around the mean. If data is symmetrical, it has zero skewness. If it's stretched more to one side, it's skewed. Positive skew means a longer tail on the right, while negative skew means a longer tail on the left. Skewness helps us understand the shape of data and whether the mean is a good summary. Kurtosis measures how peaked or flat a distribution is compared to a normal distribution. High kurtosis means more values are in the tails, while low kurtosis means fewer. This helps us understand the likelihood of extreme outcomes and whether our data has more outliers than expected. Percentiles and quartiles are ways to divide data into parts. A percentile tells you the percentage of values below a certain point. Quartiles split data into 4 equal parts. The median is the second quartile. These measures help us understand the spread and position of values within a dataset. Sampling methods are the ways we select a sample from a population. Common methods include random sampling, where every member has an equal chance, and stratified sampling, where the population is divided into groups. The method chosen affects how representative and reliable the sample is, which in turn impacts the conclusions we can draw. Bias refers to systematic errors that can distort results. It can occur in data collection, sampling, or analysis. For example, if a survey only includes people from one neighborhood, the results might not represent the whole city. Recognizing and minimizing bias is essential for trustworthy statistical conclusions. Hypothesis is a statement or prediction that can be tested with data. In statistics, we often use hypotheses to compare groups or test relationships. For example, you might hypothesize that a new teaching method improves test scores. Hypothesis testing helps us decide whether the evidence supports our ideas. In hypothesis testing, we start with two competing statements: the null hypothesis and the alternative hypothesis. The null hypothesis usually states that there's no effect or difference, while the alternative suggests there is. Statistical tests help us decide which hypothesis is better supported by the data. P-value is a number that helps us decide whether to reject the null hypothesis. A small p-value, usually less than 0.05, suggests that the observed results are unlikely to have happened by chance. P-values are a key part of hypothesis testing and help us judge the strength of evidence. Confidence interval gives a range of values that's likely to contain the true population parameter. For example, a 95% confidence interval means we're 95% sure the true value lies within that range. Confidence intervals help us express uncertainty and provide more information than a single estimate. Significance level, often denoted by alpha alpha, is the threshold for deciding whether a result is statistically significant. Commonly set at 0.05, it represents a 5% risk of concluding that an effect exists when it doesn't. Setting the significance level helps control the chances of making errors in hypothesis testing. Type I error occurs when we wrongly reject the null hypothesis, thinking there's an effect when there is. Type II error happens when we fail to detect a real effect. Balancing these errors is a key part of designing statistical tests and interpreting results. Regression analysis is a statistical method for examining the relationship between variables. It helps us understand how one variable changes in response to another. For example, we might use regression to predict sales based on advertising spending. Regression is widely used in business, science, and social research. A scatter plot is a type of graph that shows the relationship between two variables. Each point represents a pair of values. Scatter plots help us spot trends, patterns, and outliers, making them a valuable tool for visualizing data and exploring relationships. The central limit theorem states that, given a large enough sample size, the distribution of sample means will be approximately normal, regardless of the original data's distribution. This powerful concept allows us to make inferences about populations even when data isn't perfectly normal. ANOVA, or analysis of variance, is a statistical method used to compare means across multiple groups. It helps determine whether any differences between group means are statistically significant. ANOVA is commonly used in experiments and research to test the effects of different treatments or conditions. The chi-square test is used to examine the relationship between categorical variables. It compares the observed frequencies in each category to what we'd expect by chance. Chi-square tests are widely used in surveys and experiments to test for associations between groups. Time series data are observations collected over time, such as daily temperatures or monthly sales. Analyzing time series helps us identify trends, cycles, and patterns, making it essential for forecasting and planning in business, economics, and science. Descriptive statistics provide simple summaries about the sample and the measures. These summaries can be graphical or numerical, such as charts, averages, or percentages. Descriptive statistics help us quickly understand the main features of a dataset before diving into deeper analysis. Inferential statistics go beyond describing data. They allow us to make predictions or generalizations about a population based on a sample. Techniques like hypothesis testing, confidence intervals, and regression analysis are all part of inferential statistics, helping us draw meaningful conclusions from limited data. Statistical significance tells us whether an observed effect is likely due to chance or represents a real difference. If a result is statistically significant, it means the evidence is strong enough to support a conclusion. This concept is central to interpreting research findings and making informed decisions. Reliability refers to the consistency of a measurement, while validity is about whether the measurement actually measures what it's supposed to. Both are crucial for trustworthy results. Reliable and valid data ensure that our statistical conclusions are accurate and meaningful. Ethics play a vital role in statistics. It's important to collect, analyze, and present data honestly and transparently. Misleading statistics can have serious consequences, so statisticians must follow ethical guidelines to ensure their work benefits society and maintains public trust. We've covered a wide range of basic statistical terms, from data types and measures of central tendency to hypothesis testing and ethics. Understanding these concepts is the first step toward confidently interpreting data and making informed decisions. As you continue exploring statistics, remember that these terms form the foundation for more advanced topics. Keep practicing, stay curious, and you'll find that statistics is a powerful tool for understanding the world.